Morning children, we are going to learn about the theorems based on circles. Theorem 10.1. Equal chords of the circle subtend equal angles at the center. So what is given in the question? Equal chord. What is to be proved? The chord subtend equal angles at the center. What is the meaning of this one? That means AB we are taking as a chord. Then AB is making an angle at the center. How we can find out? By joining the radii. So that angle AOB is made by the chord AB at the center. Clear? Angle AOB is the angle made by this chord AB at the center. Similarly, what you can say about CD? Angle COD is made by the chord CD at the center. Right? Now what we have given the equal chords. That means AB equal to CD. Right? AB equal to CD is given. Now what we should prove? The equal chords, that means AB and CD subtend equal angles at the center. That means making equal angle at the center means angle AOB equal to angle COD. How to prove this one? Easy only. So meaning of the statement, make it clear. Subtend means nothing else. It's making an angle at the center. So what is given in the question? AB equal to CD, or we can write chord AB equal to chord CD. Okay, to prove angle AOB equal to angle COD. If you are writing a construction, join OA, OB, OC, OD, that is also correct. Without that also we can prove this theorem. Because when we are making the angle AOB, OA and OB must be joined. So here proof in triangle AOB and triangle COD. Yes. What are the criterias are equal? The first equal is AB equal to CD. That is chord AB equal to chord CD. It is given. Now what is equal? The next part. When you see the diagram, OA, OB, OC, OD, all are radius only. See, all are radius. What about the radius concept? All radius are having same length in a circle. So we are taking that OA first. I am taking OA first. OA equal to either OD also you can write, OC also write. We can write from the second triangle. So OA equal to OC, and similarly OB equal to OD. Convenient way we are writing. So both are radii. Now how many sides we got? 3 sides. So triangle AOB is congruent to triangle COD. Which is the criteria? Triple S. Now what we want from this one? Angle AOB. So angle AOB equal to angle COD by CPCT. So what is the concept here? AB and CD making equal angles at the center, hence proved. It is very easy theorem only. Once you make the idea clear from the theorem, what we can say? AB and CD are the equal chords. We have to prove that these equal chords are also making equal angles at the center. For that we have joined this OA, OB, OC, OD, and 2 triangles we have got here. Now when we compare OA, OB, OC, OD, all are radii only, so all the length are equal only. Now equal chord is also given, so AB and CD are equal. So AB equal to CD we have taken, then first radii OA equal to OC, second pair OB equal to OD. Now we got 3 sides, so triangle AOB congruent to triangle COD, triple S criteria. From this, angle AOB equal to angle COD, then CPCT, hence proved. Now theorem 10.2 is the converse of the theorem 10.1. That is the previous theorem's converse only. Now what they are telling, the angles subtended by the chords at the circle at the center are equal. That means angle AOB equal to angle COD. If they are equal, then the chords are also equal. Then we should prove this time AB equal to CD. So this time angle AOB equal to angle COD. So given, I will write here. This we interchange given to prove now. Given became last time's prove to prove became given. That is angle AOB equal to angle COD. To prove AB equal to CD. Again, two triangles for we have to take for proof. In triangle AOB and triangle COD. Okay, OA equal to, I can write OC. Already you understood the concept last theorem. What is the meaning of OA and OC? Both are radii. Now OB equal to OD. Second radii also we have taken. OB equal to OD. We can make both equal only because radii means it is equal to same length. Now one more, the two sides we got. The third side we should prove. So we cannot use that one. But the angle is given here. That angle is also included angle only. So angle AOB equal to angle COD. That is the included angle which is given in the question. So therefore triangle AOB equal to congruent to triangle COD. Which is the criteria this time? It is SAS because two sides and the included angle. Now what you can say about AB? AB and CD are equal by CPCT, hence proved. Easy only, just a little bit change in the concept. This is the converse of the first theorem. So what we have taken this time? OA equal to OC, OB equal to OD and angle AOB equal to angle COD. Therefore both the triangles are congruent by SAS criteria and therefore AB equal to CD. The chords are equal. Exercise 10.2. Prove that equal chords of congruent circles subtend equal angles at the center. We have given that equal chords this time. That is, it is similar to our 10.1 and 10.2 theorems only. Last two theorem, whatever we have proved, based on that only this exercise 10.2. But what is the change here? The change is that congruent circles. Last time we have taken that it is in one circle. One circle, definitely we know that the radii are equal. Now what is the step here? Congruent circle. What is the meaning of a congruent circle? When two circles are congruent, then their radii are also equal. You have studied. So already we have studied in 7th class, I think. So we have studied that when the two triangles, two line segments are equal or congruent, then their length are also equal. There only we have studied that when angles are congruent, their measurement are also equal. What is the meaning of the congruent of the circle? When the two circles are congruent, then their radii must be equal. So last time in one circle we have taken, so all the radii are equal. Now this time we are taking two different circles, but both are congruent. By question, both are congruent. So what about the radius? Both the radius are same only. So OA equal to OC and also OB equal to OD also. So anyway you can write the name pair. So here we got the radius. Now one more sentence is there, prove that equal chord. That means AB equal to CD. So now I think you got the idea. Two sides and to three sides we got equal. So by SSS criteria these two triangles are congruent. Now how to write? See, given two congruent circles with the center O and O dash. This is the point you should mention because both O only I have written. After writing this, it must be clear to you. For the first circle, if we are marking O as a center, the second circle we should need one other center is there. So we should use other letter only. So let it be O dash. Right, otherwise C also you can use any other letter also. Commonly O and C only for denoting the centers. So O and O dash. So congruent circle only. Therefore what we can say, OA equal to OB equal to OC equal to OD. Let us take it is equal to R only. That means all the four lengths are equal. Now to prove, what is to be proved? Same as our theorem 1 only. We have to prove that equal chords are making equal angle at the center. So angle AOB equal to angle CO dash D. This is the change. angle CO dash D. Now proof. Construction, if you want, we can write OA, OB join, and also OC, O dash C and O dash D. So in triangle AOB, comma, what is the next triangle name? Triangle CO dash D. The first is that AB equal to CD equal chords. So it is given in the question. Now what is the next one? OA equal to O dash C radii. Similarly, OB equal to O dash D radii. Therefore, triangle AOB is congruent to triangle CO dash D. So, which is the criteria? 3 sides are there. So, SSS criteria. Now, what is the result for this one? AB equal to CD CPCT. So, hence proved. Sorry, we have to prove the angle only here. Angle AOB equal to angle COD CPCT. Hence proved. What we have to prove? Equal chords. Already we have taken AB equal to CD in this. So what we is to be proved? Angles are also equal. So AB equal to CD, OA equal to O dash C, OB equal to O dash D. We got 3 sides. So the 2 triangles are congruent. By this what we can write? Angles. Which are the angles? Angle AOB equal to angle CO dash D. CPCT. That means equal chords are subtending equal angles in the case of a circle as well as a congruent circles. So hence proved. Second question, prove that if chords of a congruent circle subtend equal angle at the centers, then the chords are equal. Again congruent circle only. So what is the concept? The radii are equal. Now it making equal angle at the center. That means angle AOB equal to angle CO dash. Again, just as like our theorem 10.2 only. Here different circle, that is also congruent circle we are taking. There we have taken only in one circle. So converse, what is given? Now I think you understood the idea, so we can go fast. Angle AOB equal to angle CO dash D, where O and O dash are the 2 centers of the given congruent circle. To prove AB equal to CD. Again proof. In triangle AOB and triangle CO dash D, what is given in this question? Angle AOB equal to angle CO dash D. Given OA equal to O dash C, OB equal to O dash D. Both are radii reason. We got 2 sides and included angles similar to our proof, theorem proof. So triangle AOB is congruent to triangle CO dash D. Criteria is SAS. Therefore, AB equal to CD. CPCT hence proved. Okay. If we understood the theorem 10.1 and 10.2, the first 2 theorems of this chapter, this exercise is very easy to complete. What is the difference between the theorems and this questions? Only the word of congruent circles. There we have considered, in theorem we have considered only 2 in one circle, but here 2 circles are there, but the radii are same. So the same steps, same criteria, everything is same, but the different names, where the changes comes in only the center, right? So here what is given in the question? Already given that angle at the center is equal, we have to prove that chords are equal. That means angle AOB equal to angle CO dash D, OA equal to O dash C, OB equal to O dash D. Now triangle AOB congruent to triangle CO dash D SAS criteria. By the result, what we can write? AB equal to CD, CP, CT, hence proved. Okay, again circles is geometry part only. It is also one of the important topic. So learn the theorems thoroughly. With this today's video I am winding up. Thank you.